All right, man. Good to see you too, DJ. Man, I have a whole bunch of randomness, and I've got a bunch of people asking me questions about oscilloscopes and about how do I measure this, measure that. So I figure this would be the absolute best place to do it. Let's just go over, whatever they have questions on, from adjusting your probes to selecting a probe to the different functionality like trigger. So I have a variety of stuff here. I was just actually going through my kit to see if there's anything else I want to pull out of it. Nope. All right. I'm the wannabe Biomed. Hey, Angela, how you doing? Oh my gosh. You know something? Oscilloscopes are way easier than they ever used to be, especially with some of the nicer ones like Fluke. This one here, you got to work at it a little bit, but it, for $300, which is what I paid for this guy over here. And this guy here, I only paid $30 for. And this is a kit. Like you fold the PCB and you solder some of the components on and you clamshell it back together. This is a kit full of components and you solder them together. That guy actually does some stuff that this one don't, and that I know of. But that's okay. I wonder if this guy has got some software that you can upgrade. Bet you it does. It's still a pain. Well, guys, I'm going to make it a wee bit easier for y'all. Actually, because last week I had to fabricate a stool system for me to sit on, I said, what the hell? I'll go out and I'll get a new one. And I actually made a mistake. And I got two different ones. So I've got this one here, which is the Work Pro. It's not showing up too well, but this thing is bright green. It's crazy. Look at this guy. And this right here goes way up. Look how high this is. And I accidentally bought a second one because I always add stuff to my Amazon cart when I'm browsing through and I think it's something I really like. I'll add it to my cart and then I'll add something else to my cart later and I'll go back to the cart and then I'll edit what I don't want. Well, this is one of those times where I made a mistake and I bought two things. And one of them is the SunX stool with a backrest. And the other one is a Work Pro. And I can tell you right now, like, the Work Pro is fantastic. It's heavy duty. This thing is serious business. And this guy here, the SunX, it's just very comfortable. They all have their pluses and minuses. But I had to get a stool that's really high because of my workbench height. And then plus, as you guys see, I have a CNC over here. So I have to have something lower so that I can wait over by my console while I'm finishing a cut. So I have to have something that's reasonably high because normal stools are really low. But I've got two really good ones here. The SunX. Man, I kind of dig this one. It's got two rows But I got these stools because when I'm doing these live streams, it is such a pain for me to stand still. And the stool helps keep me in frame because I stay in one spot. That's really high. I like that. I do think I dig this Work Pro better. Look at that. Look at this. How could you not like that? Oh, hey. Bjorn. Hey, man. Welcome back. It's got to be like 2 a.m. for you. Oh, my gosh. So what I wanted to do is, on the record, I wanted to, I know I didn't advertise this or anything. Today has been one of those days, let me tell you. I wake up in the morning, you know, you wake up, you got some relationship problems, and then you've got stuff to do, you know. So, of course, you got to get the stuff done, the stuff that you still got to do. So I've been focusing on work inside the house. I installed like new lighting systems in the house, like a slave light, so it's slave to the master room light. Some pretty cool stuff I did today, and I had to get a special tool to do that. And I want to show you guys this tool because this thing is so cool and it's so inexpensive. I had to buy it, right? And if you can't tell, like, I'm a nut for tools, but I had to buy it. This guy right here comes in a hard kit. It's got a hard display that's wired to it. This is IPX7 certified, which means you can submerge it completely in water. And it's got a series of these little hooks that attach to the end of it. This is a camera, okay? So it's got this long, semi-rigid cord. And what model is this? You know it's a good one when they don't even mark the model on it. I have no clue what brand this is. Yeah, I do. Never mind. I love Amazon. If you guys don't know, like, this dude loves Amazon. Let's see. Yeah. What's up? Ready. Oh, excellent. Come eat. Un momento. Okay. All right. So let's see. So this is an inspection camera. It's an 8mm Cliff bore scope with a 16.5-inch cord. Got it off Amazon. It's like $60 some, maybe $70, and it comes with a hard kit. It's got all these little attachments that you screw on the end of the camera, and it's IPX certified. And let me tell you, there are so many times when I needed an inspection camera. And the cool thing about this one is I don't need my phone or anything like that. I just bring the kit, and you hold the button here, and it boots up. It takes a little bit for it to boot. Once it's up, look at that. How cool is that? And it's waterproof. So this little camera kit right here, I had to fish it from the main light in the middle of one of my bedrooms over to, you know, 2 or 3 joists away to a drop where I was going to create another light. So I slaved a light off the main light. So when that one comes on, this one comes on too. And I had to have this because when they built my house, you know, they cut holes in the joist so that you can run wiring through. Well, there's no real way of getting to those holes without seeing where they're at. So it's been a long day, guys. It's been a long day. So anyway, I'm going to tuck this guy away. This is a waterproof camera system, and it's only $60 or $70. I cannot tell you how many times I wish I had this when I was working on sterilizers, because if you have an occlusion in your pipe or something, you got to figure out what it is. Like, let's say the users flush something down the drain, and you got to pull something in there to see what it is. You got to stick your head in the hot ass chamber, or you could just stick a scope down in there and take a look, right? I've had this problem with scope washers. I've had this problem when you drop a tool inside a device. How many of you guys have ever dropped a tool inside a surgical table? I've done it so many times, it's not even funny. And the problem is if you start fishing around for it, you could scoot the bit or the tool further back. And that's a problem because nobody wants to take a surgical table apart. Not only is it disgusting, but it's extremely difficult, okay? So it would be really nice to have a visual aid while you are doing that. And this thing for $60 or $70, I cannot tell you how nice it is to have an inspection camera. So this is going to go on my tool stack over there. What a fantastic piece. This is definitely going with me back to work. Oh my gosh, do I do repairs on MRI machines? I have. Involuntarily, I have. I've had, I was on call once and a water pipe overloaded the hot water heater. And because it overloaded the hot water heater, it splued all over the tray. You know, at the bottom of the hot water heater, there's a tray that collects overspill water. And normally there's a drain, but there's a little rubber flapper on there on new developments. And the rubber flapper keeps sewage gases from coming up into the room. And the rubber flapper had been so old that it failed to go down when the water filled the pan. So the water overflowed the pan and went all over inside my MRI, through the ceiling. And if you guys know anything about MRI, the entire room is got copper surrounding the MRI, okay? Because copper is non-ferrous, so it's non-magnetic, but at the same time, it eliminates external noises and it prevents noises from the MRI from getting out, you know? So it's a giant Faraday cage, okay? And so it's built into the walls. And anyway, so the water came in, flooded out the entire MRI room and whatnot, and I had to sit there and dry everything out over the course of a weekend, and we ended up saving the MRI. Who figured? Water pipe blew up right over top of it, flooded out the entire building, and we saved the MRI. It's amazing. 2 a.m. Oh my gosh, you guys, I have so much cool stuff to show you guys. Yeah, this is not a Pelican kit. This is a Chinese knockoff and then some. It's you can tell by the cheap latches. I don't care. Any tough case will do for me. It protects the camera system and I can throw it in my kit. I'm good. And the other thing is I inventory everything in my kits. Like right here's my little clamps. When I seal these guys up, I know exactly what's in there, all right? And I'm like that with all my tools. So if somebody borrows it, I inventory it when it comes back. Because people always, if it's not theirs, they tend to leave stuff behind or not return it as a kit. And I'm a big fan of keeping kits together. And you guys seen earlier, I had my oscilloscope kit. And this is my secondary probe for my oscilloscope. And I am all about keeping it together. And I promise you, this is going back in there as soon as this video is done. But all my kits are put back together as soon as I'm done with them, because there's nothing worse than asking for like a tap and die set or a drill bit index, or let's say a wrench set, something, and the thing that you need is missing. There's nothing more annoying. And Biomeds are infamous for that. They're infamous for messing up a good thing, okay? So I keep all my kits together. This guy is going back with all my tools that are going to be going back with me to work. Oh my gosh, guys, I have some real good stuff here. I don't know if any of you guys oh my gosh, Bjorn, that is not funny. I'll tell you what. Have you guys seen the YouTube videos of the doctor that takes a wrench, like a regular wrench, and he suspends it from a cable, and they have that hooked up to a tension meter, and as he's ratcheting it closer and closer to the magnet, he's reading off the amount of pull on just a little tiny wrench. I mean, it's a wrench just a little bit bigger than this. And he had over 210 pounds of force. Now, I have 200 pounds, and 210 pounds means it is pulling me, okay? And that's just a stupid little wrench. So, yeah, MRIs are no joke, man. I've definitely done work on them. The time that I was mopping up all that water around the MRI, well, guess what? You can't shut off an MRI. It's always on. and I'm mopping in the room with an active MRI. And not only was that probably stupid, and I'd probably do it again, but as I'm mopping, I noticed that my mop was getting very difficult to just mop the floor. And then I just kind of eased up my grip a little bit, and the mop got pulled over to the magnet. And down in the mop head, there was a metal rod that was holding all the brush filaments for the mop head. There's one little metal rod was stuck in there, and it was holding all the filaments in there. And with me mopping, it was, you know, entering a high Tesla. If you guys don't know, a magnet is rated in Tesla, and a typical MRI machine is 1.5 to 2 Tesla. Some of them are 3 Tesla, and some of them, if you guys have been keeping track, they have 7 Tesla, I think. 7 Tesla magnets for MRI. That is incredibly strong. Guys, I don't even know if people can fathom how strong that magnetic field is. But at 1.5 to 2 Tesla, that is enough that you cannot hold something like this. Not even close. Like, it'd rip it right out of your hand. So go on YouTube, look up MRI accident or MRI tools, and you'll see like tools getting ripped out of people's hands and stuff. It's very entertaining. All right. So I wanted to show some people some stuff about oscilloscopes, because I've gotten many questions about oscilloscopes lately, and I'm going to go through. I have a function generator here. Look at this little guy. This is a full function generator. Now, it might not be as perfect as some of those big BK whatever, but this little guy does the trick, man. It does a nice job, and it's inexpensive. It's only $50 or $60, I think, off of Amazon. I don't know if you biomeds out there use hot glue, but I tell you what, this guy can save your bacon. It has definitely helped me out quite a bit. Not only can you shoot some of this down next to, let's say, a transformer that's vibrating or something near another element, you shoot some hot glue in between it and it suspends it. All right. Hot glue is non-conductive, and it's a low enough temperature where it doesn't damage any electronics or anything, you know, in the periphery. Hot glue is some good stuff. If you see some damages, let's say you have a cord that is constantly getting pulled out, you can shoot hot glue around it and technically not have to worry too much about it, because, I mean, like I said, it doesn't damage anything. It's non-conductive, and if you need to get it off, you ever need to get this stuff off of something, freeze it. And by that, you take some of that air duster, you flip the can upside down, and you frost it, all right? And it will snap right off, come right off. But hot glue is a special type of thing, because the hotter it is when you apply it, it's more dangerous to you, but the better it sticks to stuff. So this DeWalt is probably the best hot glue gun I have ever used, and I've used a ton. Trust me, I've used way beyond the amount of glue guns that I probably should have. But I used to make like custom radios and jukeboxes and stuff, and having a nice glue gun is what it's all about. Now, I have had one of these DeWalt guns go bad on me. I don't know why. Maybe it got dropped or something by somebody else, because a lot of people borrow my glue guns all the time. But I'll tell you what, this guy gets hot in probably about 15 seconds, and it's ready to squirt some glue. This is the glue gun to get. And I do actually keep this in the bottom of my tool chest, because you never know when you need to use something like that. And I've used it for when you have to clamshell something back together. Let's say a plastic stud or something ripped off. You have to get it back together because they need to continue using it. Let's say you pull apart a power supply, and it's hermetically sealed. But if you break it apart, you can, of course, use hot glue to seal it back together. And I'm talking about those external power supplies. You know, those little, let's see. Shoot, I know I probably have one of them around here someplace. Here we go. Here we go. In case you guys didn't know, inside of these things is a fuse. And you can very carefully, with a tiny flat blade screwdriver, you can work around the edges and listen for the little cracks. and you can separate these cases, and you can change out the fuse when it pops. And I have had some of these successfully restored. I've even recabled some of them because the cable will go bad. Just run a new cable out of it from maybe another power supply. What's up, booger? Come here. Come here. You want to come up? Okay. All right, come here. I know. Why don't you just come here? There we go. Okay. You gonna help? Okay. All right. Why don't you explain the function generator? This guy. You want to explain it? Shoot, she knows how to turn it on. I'm actually kind of surprised. Okay. Here. What you doing? Are you done eating? Yeah. Okay.
I ate all my food, but Seth didn't.
But Seth didn't. Should he be punished? No, don't do that. Okay. All right, so let's get back on it. I went over the video scope. I went over the hot glue gun. I highly recommend those guys. Yes, they can. If you pull the trigger before it heats up, you are absolutely right, man. DDS 100. Oh, you got the DDS 100 with an earth connector. It's best to use a hot glue gun with earth connector. I've used some cheap hot glue guns to damage a few electronic boards. No kidding. You know something? Maybe I'll have to do some research on that. An ESD safe hot glue gun, because in another video I talked about using. Well, you can see they use hot glue on some stuff, like right here. Some of these capacitors that float in the breeze. You can see on these larger ones, they clearly have hot glue just squirted on there. You see it right there. But there's this product, I think 3M created it, and it's called Oscilloscopes. And you can see that's this stuff that kind of squirts on liquidy and it cures kind of quickly. And they shoot it on components that wobble around quite a bit. And it's called Oscilloscopes. But hot glue works just as well. And Condor, which is one of the biggest producers of power supplies, you can see that they clearly use it on some of their componentry. So if it works, it works, man. Let's see. Let's go square wave, triangle. Great. I'm gonna set my function generator. I got a FG100 DDS, and I'm gonna set this function generator to 1 kilohertz. Now, I do not necessarily like this interface. It's got power, mode, cursor, which moves the cursor positions. It's got a plus and minus button, run, stop, filter with an amplify button, which I guess I kind of like that, the amplitude. And it's got a DC offset. But I would rather have the up and down function be a potentiometer, but it's not. And I don't understand that. But anyway, let's go ahead and set it for 1 kilohertz. See right there, it says square wave 1 kilohertz. Then we have to hit run. And down here at the probe, you can see I have my reference connected to black, and I've got my actual probe connected to red. This is just a little jig that's connected to a BNC connector, and that goes to my oscilloscope. Now, I wanted to talk to you guys, and this isn't necessarily for you guys online. This is for posterity, guys. People are going to watch this video for years to come, so I want to go over this in entirety. So when you get an oscilloscope, you get your probes just like this. This is a kit. It's unopened. I haven't touched it yet. And this is a typical probe. Come on, let go. All right. Let go, let go, let go. Let go. Okay. So this is a typical probe. You have a BNC with a tiny, tiny little hole on the backside. You have this part right here, which is your touch probe, and you have your reference line. Okay, you see how I just pulled that off? There's a tiny little gap on your probe where your reference line will connect. And then you see this tiny little tip right here. That is your actual measurement point, which I like using these clip hooks. I like using these clip hooks because then I can set it and forget it. But the other thing I got to let you guys know is on your probe, there's always a 1x, 10x, or 10x and 100x. And I've seen some probes that are way higher than even that. But you have to take notice of what your probe is set at, okay? So mine is currently set at 10x, all right? And what this does is it adjusts an internal resistor, okay? And that's your attenuation level. Attenuation basically means that you are decreasing to scale, okay? So not just decreasing, you're decreasing to scale. So let's say I have it set at 10x and I'm measuring 100 volts. Well, at 10x, I'd be reading, what, 1,000 volts, I think? So if I set it to 1x, actually, the inverse of that. If I'm measuring 100 volts at 10x, I should be measuring 10 volts. At 1x, if I'm measuring 100 volts at 1x, it'll measure 100 volts, okay? But here's the thing. If you set your meter correctly at 1x or 10x, then it will read correctly, okay? So you have to make sure that whatever your probe is set at, 1x or 10x, that your meter integrally is also set. So I'm going to boot this bad boy up. This is a horrible example, guys. It's a horrible example, but it's what I have. So let's see. Hey, where's your shoes?
Your food is getting cold because it's ready.
What?
It's already almost dinner.
Oh my gosh. Are you serious?
Yes.
Okay, thank you.
Yes.
Okay. All right. So let's see. I'm going to go into channel A because it's connected to channel A. This is a 2-channel scope. You can see these little BNC connectors at the top. Yes, they are plastic. So if I go into channel A, now I can set the functions for channel A. And you can see right here, maybe, see how it says V1X, V10X. So your 1X and 10X, whatever you adjust on your probe, you adjust on here. And you have to be cognizant of both of those, you know. So you set your probe, like I usually set one probe at 1x, one probe at 10x, and I just remember that, you know. I hardly ever flip back and forth. Let's see, what else can I say about this at this point? Here, I'm going to change it. Whew. Boy, this probe goes way up. Yeah, okay, V1X. All right, so a few other things that you can see for setting up your channel. You can enable, disable on this multimeter. You can set your coupling. So one of the things that you are going to set is your type of coupling on your oscilloscope. Like on this guy right here, you can see it's got a physical switch that says AC coupling, DC coupling, and ground coupling. Now, this would be a long video if I were to explain coupling, okay? When in doubt, I highly suggest just doing some more research on whatever it is that you are searching for, because something like a power supply, you could have AC coupling or DC coupling. It depends on what you are measuring, all right? So if you're only measuring, let's say, a signal on a DC only device, then DC coupling. I think I keep my meter almost always on DC coupling. Let's see. I'm going to exit out of here. All right. I'm going to leave this as best I can so that you guys can see it, and then I'll pick it up and show you. So I have my function generator set to 1 kilohertz. That's 1,000 hertz square wave. And then I'm going to connect my probe, red, to my main. Now, mind you, this is only setup. This is only setup, guys. I'm not taking measurements right now. This is me setting up the device. Okay, you can see the square wave on there. Press the auto button just to be sure. Now, you can see I have a blue line across the middle, and I have the orange line That is because I currently have my meter set to channel A and channel B. So I got rid of the blue line because I turned off channel B, which is this one over here. And here we are. This is my 1 kilohertz wave. Let's see, it should say on there. Yeah, it says right here, frequency F colon, it says 999.93. So that's 1 kilohertz square wave. And here is where we are going to make some adjustments. In your kit, and this is why I suggest you keep your kits together, because inside your kit, there's going to be a variety of tools to help you set up your probes, okay? So here you can see some marking identifier rings. I have, let's see if I can get it all out. So I have a little isolator tip. This is an isolator tip. It just pushes on the end of this guy. Come on, push on there. There we go. So you take off your clip and you push this guy in there, and you can see how it's got plastic all around it. And it's got just the tiny, tiny little pin in the center. So it's isolated from everything else. Even if you have to push another component out of the way to touch a pin, this here makes sure that you're only touching one little thing. And it surrounds the end with plastic. These are cool little parts, but you have to make sure that you keep them in your bag, okay? Because this stuff always gets lost. At Biomed shops everywhere, they always lose these components, including this guy, all right? If you guys have the old Tektronix scopes, the CRT type scopes, etc., some of the best ones in the business, this little tool right here is a tweaker. And the reason you use a tweaker, no, it's not a druggie. It's not, it has nothing to do with drugs. Your tweaker is for this guy right here. I referenced earlier, I said that there's a little hole in the side of it. That is to adjust the resistor inside your probe. On the side of all sorts of oscilloscopes, including this little guy, you can see right here, you can see, what does it say? It says square wave 1 kilohertz. This is a reference point, okay? And a lot of the better oscilloscopes, not this one, as far as I can tell, this one doesn't have it, but a lot of the better oscilloscopes has a calibration point, okay? And that is to set up your probe. So the thing is every single probe is going to have some attenuation. It's going to have some difference of potential. There's different characteristics of every single probe. So before you take a measurement for accuracy, you hook up your probe to a function or signal generator like this guy, and you set a perfect square wave to your oscilloscope. And then watch what happens when I adjust this guy. All right, I'm gonna set this guy in here. I don't know if you can see it. Where we set it. Okay. Okay, see it on here? You see how the square wave is not necessarily square? See how it's got that spike? So what you're going to do is you're going to slowly tweak your probe until your square wave is almost a perfect square, okay? Because you need it to know what a perfect square is so that you can get an accurate frequency reading. It's absolutely paramount, especially if you've got those old oscilloscopes that have been sitting around in a closet or something. There's always like a calibration port on the front where you have a ground point and then you have a 1 kilohertz or 100 hertz, whatever it is. You have a point on the front of it that you're going to clip. You're going to clip your lead onto that point, and then you're going to calibrate the probe to a perfect square. Once you get it to a perfect square, now you're ready to start doing some measurements. So let me calibrate this guy just a little bit more, just to make sure. So it's that leading edge of the square that we're technically adjusting. So you can make it sag, or you can bring it up. Right there. Okay, now my probe is perfectly adjusted. It says that it is 99.93 kilohertz, just close enough. And now I disconnect it from my signal generator, and I am ready to start taking measurements. Now this guy here, I don't have to worry about very much from here because it's a battery powered oscilloscope. And I've said in other videos that only oscilloscopes that are hardwired to the wall, those are the ones that you have to worry about, because the B and C outer part of the port is connected to earth ground. This one here, I don't have to worry about that. I've never smoked this one, and I've done some risky measurements. At $300, it's almost worth a gamble, you know. So when I'm probing around, referencing random spots, I can be reckless. Now there's boards that I said in other videos where my my heat sinks were hot because I've had components that shorted internally, and I've gotten shocked by touching the heat sinks. Well, in those points, if I were to have referenced on that same area, I would have probably blown up my meter, and it's going to happen. Internally, there should be a 10 amp fuse. I think it's 10 amps. Maybe I should open this guy up, huh? What do you guys think? Should I open it up and see what's inside? I've never looked inside this meter. Kind of curious. Let's see. Uh-oh, hold on. I'm trying to catch up. I have not been reading the comments. I'm so sorry, guys. Medina, Ohio. Hey, man. Excellent. The competition. I grew up in Michigan. Very good to hear. Look in the battery compartment for the compensation port. Ooh. It's a good point. Except this guy is charged internally. I don't know. Is there a battery compartment? Hold on. Let's find out. Let's find out. Because every reasonably good oscilloscope has got a calibration port, and this guy has never had it. And I guess you could always read the user manual. But you know, some Chinese products, they're not very good at explaining everything in even the user manual. That's the battery port. Heck yeah. I think I'm in business, guys. Let's do it. Come on. All right. Well, on this meter, the battery is glued down, and you see it's very simple. Extremely simple. That's kind of cool, because if the battery ever goes bad, I can find another lithium polymer to go in there. But there's definitely no calibration port in there. Now, the only other thing I can think of is maybe you calibrate off of one of the meter ports. Now, it does say over here that trigger is off the red port. So if I'm going to do a remote trigger, I do that. We'll talk about trigger in just a moment, okay? Let me get this guy back together. Now, one of the most important things that you can remember about oscilloscopes is your trigger. It's something that all oscilloscopes have, and it's going to be one of the most important things that you are going to do if you are going to try and take some serious measurements. Let's see. Let me connect this guy back up to my function generator. Okay, there we go. Okay. So oscilloscopes have this function called trigger, and trigger is normally a line, and you can probably see it right over here. See that little tan line on the edge? That's my trigger point. And right now I currently have it set at auto. When you press the auto button, it will automatically trigger to find the most clear waveform. And so what your trigger is a point of measurement. All right. So when you take a waveform on an oscilloscope, you want to move the trigger down on the wave point so that you're hitting like the crest of the wave, the very top, not above it, but you got to be in the wave point at some point. If you move your trigger down to like the halfway point, it will register your ups and your downs, and you'll get double the frequency, which won't be good. Okay. So what I'm doing, if you have signals like some television signals, some signals, maybe, hell, I don't know, maybe I'll hook this guy up and we'll check that guy out. There's a lot of signals which will have multiple signals embedded into it. Okay. And I don't think I should get into carrier frequencies and stuff like that. But what you have to be aware of is it's not always a clean signal. Sometimes there's little signals embedded in there, okay? And in order to find those, you have to adjust your trigger to select which one you want, okay? And given I've only got a square wave on there, so it's not really going to serve too much of a function. Here, let me get out of here. Channel B set. Okay, on this meter here, you can see right there, this F4 is set for trigger. So I press my trigger button, and now I can adjust my trigger up and down. So notice the tan line to the side. See me moving it up and down? So what your trigger does is it captures a section of the wave, and it stops the wave on the screen. Not in the background, but on the screen. It freezes the point. So let's say I'm trying to find a peak. My waveform's like this, and every once in a while I get an artifact that flashes really high. So if my normal sine wave is this high, you know, a sine wave is just like an S-curve wave, and all of a sudden I get some interference every once in a while. Let's say I have a sensor. I got some sensors here. All right, so let's say I have a sensor, and my sensor is registering when the door opens and closes, okay? What I would do is this point is going to be higher than the other waves that are shown. So I set my trigger above the existing waves. Let's see if I can do that to show you guys. Because what you want to do is you want to capture the wave when this event happens. And that's what the trigger is basically doing, is it's capturing the wave at the event. Okay, so you're setting the level up or down for the event. And let's see if it allows me to do it. I'm moving my trigger up, 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 up. Oh, this meter's goofy. You can see as soon as I get to the top of the square wave, it's changing the voltage. I guess I should have went over the basics of oscilloscopes to you guys. So the basics of every oscilloscope is you have voltage and you have time, okay? So your amplitude, which is your up and down, is adjusted by these buttons over here, which sometimes is a dial on nicer machines. And then your time is the amount of time between points, okay? So you can make it longer or shorter. So since I'm at 1 kilohertz, you can see as I change the frequency, I'm zooming in on part of the wave. So if I want to see the leading edge or the trailing edge of a square wave, that's how you would do it. And then I can use see how I can use these buttons here to scale over. So on the leading edge or the trailing edge, if it tells it to read a sensor or if it tells it to turn on a motor or something, you can use this right here. You zoom in like I have here, and then you can use the buttons to see the leading edge or the trailing edge of your waveform. And I really wish I had a better example to show you guys, but there's so many instances where you can use an oscilloscope, and it's going to be for diagnosing motor problems. You're going to use it to diagnose problems with your ground circuit, like if you have harmonics on your ground system, which I've had before, and it created a lot of hell for me. There's a lot of situations where you can use an oscilloscope to diagnose what's going on, and you cannot do that with a multimeter. Now, I don't care how good your multimeter is, it just won't do it. Some of the other cool stuff that oscilloscopes always have is it can record your waveforms. Okay, so let's say I'm reading 34 volts DC, and I want to record that to save that into my work order. There's almost always, on all the good oscilloscopes, there's a way of saving that data to take a screenshot and you export it. And I do that quite often. Hey, 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 hey. Are you hungry? You hungry? You hungry? I'm a good girl. Huh? You want a drink? Why don't you go outside and get a drink? You know you got a drink out there. Huh? Oh my gosh. Sorry, guys. It's either my kids or my dogs, and one of them always has to be in on it. So there's a lot of functionality to these oscilloscopes, and you guys, it's going to be different every single thing that you're going to measure. If you're measuring AC, which means if you're measuring motors or if you're measuring like wall voltage or something, you can do that with an oscilloscope, and you can take a screenshot of it and save that in your work order. Whereas you can't really do that with most multimeters. All right, so there's a difference. Let's see. Take it apart. You are absolutely right. You know something? Let's do it. I have not taken this guy apart, and I am really interested. I don't see any CAT ratings. Oh yeah, I do. It says it's Cat 2 rating 300 volts, and on your multimeter leads it says Cat 3 600 volts. If there's one thing I've learned from Chinese multimeters, do not listen to the CAT rating. Yeah, so the CAT rating is your isolation to help you as a technician. There's certain components of the circuit board internally that will be like this will be separated from your measurement, and it will be separated from you. Okay, either the amount of grounding or the amount of conductor that they put on the circuit board. There's a lot of things that make up your CAT rating. Actually, you know something? I think we're going to have a lot of victims tonight. I think we're going to take all these apart. We're going to take them all apart. So I got the Chinese multimeter. Oh, do I have my fluke? I don't think I have my fluke. I think I took it back. Oh, okay. That's okay. We're going to take it apart. And yes, I do watch the EEV blog. I've written him several times, and I actually used to watch his stuff religiously, except for the fact that the poor guy, every once in a while, he has to tell us his thoughts on religion. And if you guys haven't figured it out, I don't believe in using this platform to talk about politics or religion or anything like that. You guys get enough of that in your lives. In my opinion, doesn't matter worth a shit to you. Okay? So I don't believe in that, and I'm not going to tell you about religion or anything like that. There we go. But yes, the EEV blog is an excellent resource, man. Excellent resource. Well, let's see. When you take this guy apart, I'll tell you right off the bat, there is an extremely short cable that goes to the battery. Extremely short cable. There's no space for it. So I have to pull this back apart to get that battery lead off, and then we can take a look inside. Now, I did a video on this multimeter because I thought, man, for the stats, it was just an excellent meter, man. Not only is it a multimeter, but it's an oscilloscope, and it's color, and it's got multiple channels. And I thought, man, even if it's a complete pain in the ass to use, at $300, that's kind of a deal. Because for the really, really good multi-channel oscilloscopes, it's what, $4,000 for some of those? It's just crazy. Okay, so there's the strap. They have a nice strap that is included with this multimeter. Oh my gosh, look at you guys. They have upgraded. So you can see right here your RF shielding. It's just a thin sheet, but hey, I've seen a lot of cheap oscilloscopes that are way worse than that. So they shielded it pretty good. Just got to be careful of that battery lead. I almost pulled it off even when I was being delicate. All right, so let's pull the shielding off and let's take a look and see what's going on under there. So one of the things I'm looking at is the cuts in the PCB. So there should be a physical cut that will separate out the leads in the PCB. And I'm looking for that because that would indicate that it really is cat rated. All right, let's do this. Ooh. What is going on there? Okay. Let me pull this. Oh my gosh. Well, I can tell you I don't see any cuts in the PCB, but there is a whole other PCB underneath it. I don't know if you can see that, which is obviously your display. So you've got your Cyclone 2, that's your main processor. There are a bunch of adjustment points, so you can calibrate this. See these points right up in here? Now, I've taken a look inside a couple of flukes, and they weren't adjustable like that. I don't know if that's better or worse. Okay. And take a look underneath every single one of these. There's an adjustment point under every single one of these. Those are tiny little pots, every single one of those. And then you've got these ones up here. Yep, you got 1, 2, 3, 4, 5, 6, 7, 8, 9. You got a dozen of them in there, man. That's crazy. The soldering looks like it's really well. It looks rather nice. A little bit of flux issues down here on this port, but so when I was talking about the cat rating and having cuts, normally there's a physical cut in the PCB that separates out like your compute section from your measurement section. In case you have a high voltage influx, there's a physical barrier that it has to jump across. This board does not have anything like that I can see. And taking a look at it, wow, there is quite a bit in there. I'm not even going to play like I know what's going on. I know that you have your memory down here, but this is your main processor, and you're going to have digital analog converter and a bunch of other stuff in there. But that is a very cool meter. So next I have my $100 Klein meter, and this one here is, I don't know, I got it because it's got this rubberized coating. It's got every measurement I like. It's got a physical dial. I dig that. It's got backlight. It's got everything I want in a meter for $100. So let's take a look and see what's going on in this guy. some of these Chinese meters are getting much, much better. I mean, guys, these things have so many functions built into them that, I mean, obviously I own a few of them. Whereas before, I only owned like Fluke meters, and I've owned a Craftsman meter. I've owned a Mac Tools meter, which is a rebranded Chinese meter. But I would say that they're getting way, way better. Oh, there we go. So there's a couple other things I wanted to show you guys. I'm hoping this multimeter has I'm hoping it has fuses inside it, because that's something I did not see in my oscilloscope. I don't know why, but I did not see fuses. All right, that's what I'm talking about. Right under the battery cover. So if you see right here, I've got two bus fuses. Now these fuses are probably the big one is for amps. You can see right there, slow blow, 1000 volt, 30 kiloamp fuse. It's actually set at 10 amps. So that is for when you're doing your amplitude. So when it says 10 amp right on the front of your meter, if you go over 10 amps, you should be using an inductive amplitude probe, which I am not. I don't do amps very often. So I got somebody coming in the back door over there. Let's take a look inside and see what we got. Nice. Nice, guys. See, that's what I'm talking about. Okay, so some of the things I want to show you guys. This is, what's the cat rating on this? This is Cat 3, 1000 volts. Cat 4, 600 volts. Okay, so some of the things that make your cat rating. Take a look right here. You can see that this is a physical gap that's engineered in the PCB right there. Okay, so that is a spark gap. Okay, so that it isolates this side, this rail right here from this component, and those are found in most nicer meters. Now this multimeter right here, I do not see any potentiometers. There's no pots in here whatsoever. Maybe on the back side. I'm not going to flip it over, but you've got your inputs down here. I've got one spark gap. You see it right there? And I've got one right here by the fuse. I've got nice traces on these, man. Really nice traces where they're soldered in. Really thick. Let me show you this guy right here. Pull it in. Damn it. Anyway, what you're looking for is a solder point right here. Okay. It almost looks like it's half the thickness of the solder points right here on this multimeter. This is a $100 multimeter, built really well, really nice. You can see the springs for the alkaline batteries. The springs are soldered right to the motherboard, so you have to be wary of that. But that also means that you can repair it if it ever gets corroded. This is that's a nice, guys. This Klein multimeter is exceptional. You find it at Depot, I believe is where I found it. It's the MM700. This is a very nice multimeter, and that's why I have it here at my house, because I still do a lot of work here at home. This oscilloscope, I would venture to say that this cat rating is not very realistic. Unless, now I'm not completely up on my electronics, but I wonder if these right here are all opto isolators. You see these guys right here? Which would mean that this right here is your separation plane from your measurements to your from your input to your measurements. And these right here would be your attenuation of the LED inside for your voltage measurements. I don't know. If you guys know what those things are, I think they're opto isolators. I don't see any physical. Oh, yeah, right there. It says MDA-1A05-04L. See if you can see them. But anyway, if those are opto isolators, then that would be your spark gap, and that would make sense for your ISO rating or your cat rating. Wow. Obviously, this little bastard right here is the one that I put together, and if this guy blows up, then so be it. You know, I would not trust this guy for anything. It's a good little kit. As far as I know, the measurements were spot on. I mean, it's what is that, a JYZ Tech or something like that? But it's I've got these ones set up with a little 9-volt auxiliary battery that just kind of velcros to the back. A little cumbersome, but you just, you know, turn it on through the power button at the bottom, and you have a tiny little portable oscilloscope, which works really well, by the way. But man, I wanted to tear apart this inverter for you guys. This guy right here was going to be put to some heavy use. If you guys don't know, an inverter, this guy right here, this converts DC electricity over to AC. And what do you guys think? Should I tear it apart? Because that means that inside of here has got a bunch of switching mechanisms to imitate a sinusoidal wave, which, if you guys don't know, is what comes out of your wall. So it's got to get as close to a perfect sinusoidal wave as possible. And the way that it does that is by pulsing DC. So if you think about it, if you pulse DC and you pulse them high enough and then you bring it back down, and then your next wave you come up and then you go back down, that is how you imitate AC without using a transformer and, you know, a coil. So that's why they're able to do it in these guys. And basically, when you read that it's 1100 watts, your wattage, that's basically its cooling capacity, okay? Because once you start reaching your peak wattage, that's when it can no longer cool itself, okay? That, or you're pulling so many amps, because remember, most of these are rated at 12 volts. 12 volts at like 40 amps is an incredible amount of current. So it's going to get extremely hot. So if the wiring and the traces internally are not engineered, then you can't have that high of a wattage. You know something, screw it. Let's go ahead and pull it apart. I'll show you what I'm talking about. This guy, I bought this for a conversion van, and my kids loved it. And then when I moved here to Houston, I had to sell the conversion van. So I pulled out my inverter and I pulled out a whole bunch of stuff and I sold it. So here we are. I have an inverter. Can I show you how to use the oscilloscope in real life? You know something? I can. And I'm going to pull this guy apart. And when I pull this guy apart, I'm going to hook it up to the oscilloscope so that you can see what a synthetic sinusoidal wave looks like, okay? So it's not a real sinusoidal wave. A sine wave or a sinusoidal wave is that perfect S, right? It's nice and smooth, big up and down, and it happens here in the United States at 60 times per second. Well, this guy here imitates that by really fast frequency pulsing DC. So it's I believe they're called like chopper drivers, but they turn on and off really fast, and they pulse up and down the wave. So positive polarity, and then it pulses to the negative polarity. And that's how you get your synthetic wave, which can be very bad for electronics. So if I had this hooked up to something that had a computer chip in it, it could be very bad for it because it's not clean power. Let me put all my meters off to the side here. I'm actually very impressed on that Klein meter. Okay, let's pull this bad boy out. These are all the mounting hooks to mount it to a surface. And I think I bought this guy here at Amazon. Of course it was Amazon. Okay, let's flip it. All right. There we go. Okay, on your input plate here, you can see it's got 5 volts for USB charging. You have actually a readout which tells you your capacity. So if I have, let's say I've got 300 watts hooked up, it'll say like I'm using 30% capacity on the screen. And it will also tell me my input battery voltage. So if I've got some battery sag, so let's say I've got a vehicle with an old battery, okay? And battery sag is what happens when you start going below your typical voltage, all right? So if I hook this guy up and I start pulling a load, inside this battery is a series of plates, okay? And there's a chemical reaction between the acid, the hydrochloric acid, and the lead. And that chemical reaction eats away at those lead plates, okay? And when you recharge the battery, what you're actually doing is you're chemically changing back the surface of those lead plates, okay? So you're regenerating the ions, or you're separating the ions out from in the solution back to the lead plates. So that is what's going on. And over time, your battery gets old. So it might show 12 volts, but when you start pulling a charge on those, when you start pulling a current on those lead plates, the battery voltage will just dip really low. So that's what happens when you go to the auto parts place and they hook your battery up and they do a test on it. They hook it up to a known test load and they see how far down your voltage drops as they put a load to it. And they're testing out those plates inside your battery. And that is called battery sag, and it happens just naturally over time. Most lead acid batteries only last 3 to 4 years. That's why I keep saying in medical equipment, at 3 years, we change out batteries. So if your manufacture date on a battery is 2018 and I install it in 2020, I might give it 2 years, maybe, probably 1 year, and then we change it out. That's why we always go for the newest batteries. As soon as they come in off the truck, I open up the package and I start reading the manufacture dates on my lead acid batteries because we like batteries as new as possible. The older batteries, they've been sitting around for a while. They've got you know, an old charge on the cells. It's just not a good idea. Oh, that's very cool. Okay. So this guy here, you can see it's got an upper clamshell and a lower clamshell, and these are extruded aluminum. And that, this is extruded aluminum right here. And this is what I built my CNC machine out of. So what they do is they have a die and they force with incredible amounts of hydraulic pressure. They force the aluminum through this die, and it comes out in the shape that you want it to. And it's called extruded aluminum. Check it out on YouTube. It's very cool. So you can see that what they did is they have an upper and a lower that kind of slide into each other. So if I loosen up the screws, I should be able to slide the top right off. Hold on, man. I'm going to show you guys in real life what my oscilloscope can do. It's just going to take me a minute because I've got to put my oscilloscope back together. All right. There we go. That's what I'm talking about. Okay. You can see how the extrusions slide on this little gap here and here. And that's the crazy thing about extrusions. Extrusions, you can get a lot of details. So whenever you see a heat sink and it's got all these ribs and stuff, that's not machined in. What they do is they shove it through a die, like molten aluminum. They shove it through a die and it comes out that shape. So here we go. That is the inside of this bad boy. Look at this heat sink. How cool is that? So you can see my AC outputs. This is my power supply, and I don't think I can go any further inside it because what they did is they fastened down all of my MOSFETs on the side to this heatsink, so I can't pull it off. You know, that's it. But I can show you the other side. Take a look. Let's see. How can I? Let's just pull these guys off. All right. Can the camera show it? I know I can do a better job than this. What do we got? There we go. When in doubt, whip out a flashlight. Okay, you guys see up in there? Right there are 3 40-amp fuses. So if this guy ever fails, instead of having external fuses where you can just change them out like on a car audio amplifier, they have them inside. You think they did that on purpose? You betcha. So if you ever blow it up, you just go and get another one. You can't fix it. Most people just throw it out. Biomeds, they'd open it up and they would probably fix it. So anyway, your DC comes in on these 2 posts, and then it comes into a series of choppers right here. Chopper drivers, they're on both the sides, and out comes AC, and that's what we're going to check with our oscilloscope right now. Okay. We're going to do this with this guy wide open because why not? If it catches fire, it catches fire, right? It's got all its cooling, so we should be fine. Now, I'm not going to put a serious load to it. All right, so let me see. Let me put my oscilloscope back together so I can show you guys how this really happens. Yes. Check the waveform on that inverter. So Bjorn is probably well aware that on cheaper inverters, it's going to output at a lower frequency. So it's going to be very choppy, okay? The more expensive ones will advertise that they have a realistic sinusoidal wave, and you're going to see it. You're definitely going to see it. We're going to do that right now. I honestly don't expect this to be an expensive one, by the way. It's what, maybe a few $100s, maybe. So let me put this guy all back together. Okay. Sorry, guys, I got to catch up on your comments over here. Let's see. It's going to be a real jagged sine wave, right? That's actually right, DJ. It's going to be very jagged for sure, since it's a cheap one. Would it depend on the frequency of the DC conversion? Yes, that's exactly right. So the cheaper ones are going to convert DC over and drive it at a much lower frequency. It's kind of like sound. You know, you've ever heard of like 8-bit sound, 16-bit, 32-bit sound. They advertise it for MP3s. They advertise it for streaming. So the higher the bit sound, the more realistic to a real sound wave is. So as you guys know, real music is a perfect, sine wave, right? You flick a guitar string, you get that perfect sine wave. But then when you play it back through MP3s, what an MP3 does is it digitizes it, and it does it through compression. So you lose resolution, right? And when you lose resolution, you get that jagged. So if you're not really listening for it, it sounds the same. But when you listen to it through good speakers or with a good headset, you know the difference. All right. So think of electricity just like sound. The higher the resolution, then the more realistic the waveform. Okay. And this inverter right here is probably going to be noisy as all hell. Although it looks like it's built well. Guys, I'm looking at these solder joints and stuff. Man, these guys look like they're the real deal. Let's see, what brand is this? I don't even know. It's Krieger. Okay. That's probably why. Krieger brand. If I remember right, this thing was rather expensive online. So that would explain why everything looks very nice. I don't even think that this guy's made in China. Oh, where was it made? Never mind that. Made in China. Do you guys remember back in like the 80s and early 90s when the joke used to be that something was made in Japan? It was a real big thing back in the 80s and early 90s that it's probably made in Japan. It was automotive, cameras, stuff like that. Because the German cameras were good, but the Japanese cameras were garbage. And that was just the trend, right? Sony, a lot of those companies were just cheaper brands. Now, Japanese brands are exceptional, and Chinese are catching up, man. If you look at the ingenuity behind some Chinese products, the cost of manufacturing, I don't even know how they make these products at that price. How do you make this product right here for such a cheap price point that I can buy it for $300? I don't know how you can do it. Somebody's obviously got it figured out. I'm almost done. I've got the shielding back on. Put the strap back on. So one of the things I'll point out to you guys, this carry strap is not just molded in with plastic. What I'm doing right here is I'm putting in these stainless steel pins here and here, and they are holding the strap on. To which I just lost one of my pins. Oh well, I'll take it out. All right, let's see. Everything's back. Put the door on. Hold on, I need to get a set of pliers. I use these guys. So I know that there's this thing going on where a lot of biomeds say that we don't need to know how to operate oscilloscopes anymore. But if you think about it, I've said it before, it's part of your craft, right? So part of your craft is when the situation arises, you need to know how to measure it. So if you have, well, there's still a bunch of medical equipment that requires you to whip out an oscilloscope to document the waveform. There's a lot of ESUs, some of the specialty ESUs, like Irby, let's see, the Olympus, that in order to figure out what cut pattern that you are hitting to make sure it's correct, you have to pull it up on an oscilloscope. And that is why a lot of ESU analyzers have they have a BNC port so that you can connect your oscilloscope, because there's still a bunch of devices out there where you use the oscilloscope to help you calibrate. I know the Force FX, I did a video on that one, and to correctly do it, you have to have an oscilloscope to adjust the peak voltage of the waveform. I don't know how you would do that with a regular multimeter. There we go. All right, cool. My O-scope is back together. Let's do this. All right. So my probe is already calibrated. I'm not worried about that. Let's go ahead and hook this bad boy up. Do it on channel A. So I'm only going to be measuring 12 volts and 120 volts. So I'm going to set my attenuation on 10x on my probe, and I think it's 1x on the meter. Maybe it's 10x on the meter. I'll find out when I boot it up. All right, let's set this guy up. I'm gonna actually power this guy off a full 12 volt battery since I've got one right here. Oh yeah. All right, let's do this. Plus, I'd like to see the charge on this battery. It's been sitting around for a while, and there is an old wives' tale that if you set a battery straight on cement, that it depletes its charge over time, and that has been disproven many times, but I'll do it here just because. Let's see, hold on. Let me get some clamps because I've just got terminals. I don't know how the hell I'm going to hook that guy up with my famous jumpers. All right. You just graduated and AC is not your strongest topic, DJ. Let me tell you something. So it's funny because everybody wants to go into DC, and I get it. But if you don't understand AC, then there's a lot of stuff that's going to confuse you about DC, like noise, because noise is AC. It's always AC. It's, you know, it's harmonics. It's the waveforms that just happen. I'm underneath these LED lights, and if I turn on my oscilloscope right now, I'll show you a trick. Let's see. Can you see it? There. Okay. So when I hook this guy up like this, does it have a notch filter on there? Auto. Okay, can you see that waveform right there? Let me set it a little better. So what I'm doing is I'm turning down the voltage, and now I'm going to turn down the timing so that it pulls up a waveform. Okay. See that waveform that you're seeing on there? That is noise, all right? And that is just from my probe. You see what I did is I connected my reference to the point, and I created a loop, okay? So when you do this, especially with a battery-powered unit, you can walk around a room just like this, and you can see noise that happens especially from motors. AC motors are infamously noisy. And I wish my lead was longer so I could show you guys. But anyway, when you connect in a loop, I adjust my timing down, down, down. Okay, nanosecond, nanosecond, and millivolt. Anyway, you can see the noise that's showing up on the screen. So when I'm trying to find a noisy instrument, let's say a Bobby that's in an operating room, you can take a battery powered unit like this, you clip it over like this, and you can walk around and just kind of wander over units and you will see the waveform. It'll pop up on your screen like plain as day, especially if it's really noisy. Because every once in a while you'll have like EEG, which is when they have the brain scans. They're little electrodes that they put all over your brain. So when they go into surgery or in an EEG room where they're monitoring people that have epilepsy, sometimes stroke. So when they're monitoring EEG patients, they're looking for little tiny minute waveforms. It's very small. So when you have a noisy ass device in the room like this, maybe an LED driver that's going bad, it's going to create a lot of noise and your pattern's just going to be crazy on the screen. So this is how you can find it. You take your oscilloscope and you go into the room and you look for it. And you just wave around the equipment and you'll find it. Plain as day. You will find it, okay? All right, let's see. I'm abusing my chat screen over here. First off, I want to get back to the $5 howler I got from ESA NPR. Thank you very much for that $5. I appreciate that, man. I'm going to get this on for you so that you can see what it looks like to take a real life measurement. And let's say I'm fixing car audio amplifiers or I'm fixing these inverters. People blow them up all the time. There is electronic circuitry inside this guy. So if it gets too hot or if it's got an under voltage, because remember, if you have the same amount of load, like if I have something plugged in over here, 1,000-watt heater, if the voltage drops down, what happens to the current? The current has to go up, right? Because the output always has to be the same, right? So when voltage goes down, current has to go up to maintain the same amount of output. So these guys have special circuitry built into them to shut them off when the voltage goes too low or when the output is too hot. All right, so if I hook, this is 1100 watt, if I hook up a 1200 watt heater to it, it starts getting warm. It says, no way, and it throws a little error on the screen. I've had it happen before. So anyway, let's hook this guy up. I got my battery leads here. Let's see if I can get it. I got my plus. All right, since this is straight off the battery, guys, this is major amperage. If I short circuit this guy, like if I cross these two leads, I'm in trouble, okay? So if you're playing around with car batteries and jumper wires and stuff, just be aware of that. So with cars and with electronics, connect your positive first, right? And now I'm going to connect my negative. All right, we got it. Okay, I press my power button. Woo, it is not happy, guys. Hold on. So that's interesting. I charged this battery fully about 3 months ago. I think it was 3 or 4 months ago. and I set it here on the cement, and now it's reading 9 volts. That is not that old of a battery. Oh, not good. Oh, I know. Hold on. There. I have all sorts of tools, guys, and that's why I have a battery charger. Sometimes I just got to remember what tools I have. All right, I'm going to plug this guy in over here. And I'm going to try and place this guy further away because a battery charger creates noise, okay? And my oscilloscope is going to register that. It's going to be not good. So I'm going to try and place it off into the side. I don't know if you guys ever heard the phrase that you shouldn't ever do a live video because everything will go wrong. This is living proof that that's true. All right, let's see. What do we got? I got my 12-volt battery charger on. Okay, standard battery. Okay, we are charging, which means I should have 12 volts coming in. Or not. Or not. Let's see. I know I got some 12 volts around here. What do I got? Where's my batteries? Okay, well, the alarm's off. Something's happy. I don't care. Let's press on. Okay, I've got 10.8 volts, so I'm going to apply a really light load to it, which is going to be my signal generator. This guy's got to be pulling, what, maybe a couple watts, maybe. So I'm going to plug that guy in. Okay. Let's see how long that lasts. All right, so let's see. I have here, I've got power on my 120 volts. I've got 12 volts coming in. Let's go ahead and see what's going on. Do I have any good points? Oh, yeah, I do. Excellent. Auto. Okay. Well, I don't know if you guys can see that, but perfect sinusoid wave, it is not. Okay. Let me clip it on over here. All right, so I'm using auto on this oscilloscope. I think it's going to be way easier for me to demonstrate this to you. Okay, there we go. All right. Is it messy? Yes, it is very messy. Take a look at that. So you see your square wave up, square wave down, and that looks like absolute garbage. So it is not a simulated sinusoidal wave at all. It is plus minus 60 volts, plus minus, and it just keeps on going. Take a look at that. That is horrible. Absolutely horrible. But it is what it is, guys. And that's at 12 volts, man. So that is absolute garbage. I wonder. I guess I can use my function generator to show you guys other real measurements. I was expecting this to be pulsed at different different amplitudes. So like you would get the beginning of your wave, then the next part, then the next part, then the next part. Those would be the very expensive ones. But you can tell on this guy here, it is just pulsing plus or minus, and it's almost a perfect 60 hertz. And let's see, I'm going to show you guys the trigger function, which I'm not using the external trigger, but you can see as I adjust the wave down, this little mark over here is what I'm adjusting. And what I'm trying to do is if you get a really squirrely wave and you're trying to get an accurate frequency, you're going to adjust your trigger point up or down. And what it's doing, imagine a visible line that you're crossing up and down. And that's what your trigger is. But this guy here, I've got, I guess you could say it's almost perfect. I mean, I've got 120 volts at 59.978 hertz. And so if I wanted to continue using this to investigate the rest of my circuit, let's say I'm going to start searching on my DC side. Well, fortunately on these battery-powered oscilloscopes, a lot of times they will do AC to DC measurements automatically. You don't have to go through, like on this guy here, if you wanted to check AC measurements, you know, you have to set it on AC, and if you want to do DC, you have to press a button, right? So that's how you select between AC and DC on this meter. Button. These guys here will detect automatically if it's AC or DC, and they'll tell you, okay? Woo. Remember when I was talking about noise and you can wave something near something to see if there's noise? Take a look at this. I clipped it on. Watch when I get near this power supply. Look at that. Oh yeah, this guy's noisy as hell. You can see all those choppers, all those SCRs. So I'm going to obviously get a lot of noise while all this is plugged in. I should probably shut it off. Notice how my screen changes immediately. Anytime you have power supplies, like this guy right here, they're very noisy. Anytime you have devices like this, whether it's a power supply like this, or it does the opposite and it converts DC to AC, like this inverter, they're noisy. They're always noisy. And in medical equipment, that's very bad. That's extremely bad. Let's see, what else can I tell you guys? I'm sorry, I'm going to try and catch up on your comments. Let the magic smoke out, and somebody's going to get me in trouble. If you plug a fan in, it spins very choppy. You know, you're probably right, because fans, the frequency of the fan, you know, whenever you have motors like this guy right here, the frequency of how fast this guy can spin is based on the frequency of what's coming off the wall. So I got 60 hertz coming off the wall. If I were to use a device to increase the frequency, which I can do, then you can make this guy spin faster. This guy right here, my grinder. But that goes with all sorts of AC motors. If you use a frequency converter, you can make them spin faster than what they're supposed to. Oh, let's see. I think we know it was my internship, so final class was out in the field. During April, we did try to use Zoom, and that was working out. Man, I don't know how people are going into technical classes with Zoom. That just wouldn't work. You have to be there. You have to put your hands on stuff, and you have to take a risk, like this. If people were taking measurements of devices like these guys right here, I wonder how many times people would blow it up. I hope my screen wasn't that far off throughout this whole presentation. I just took a look and noticed my camera was way off. Michael Doyle, welcome, man. Welcome to the stream. Hold on one second. I'm trying to straighten some stuff out here. There we go. There we go. I need to have a better streaming platform. I'm thinking about putting a monitor on my back wall so that I can see what everybody's saying without turning over here to the side. It's so annoying. You know something, RDB, you are probably pretty accurate on that about the temperatures affecting the battery. Although this is a climate-controlled garage, the floor is still native to whatever's outside. So if it's 40 or 50 degrees outside, well, your floor is probably going to be about 50 degrees. If I store a lead acid battery on a steel shelf or cement floor, I put a board underneath it. You know, RDB, I do have boards right here, and it's for that exact reason, because that's, again, it's one of those things, it's been disproven to be an old wives' tale, but, you know, we all still do this goofy stuff. I have boards that I put them on. You know, not only that, but it's just weird setting stuff on cement, even at the hospital. You know, people that set medical equipment straight on the floor, it's weird, all right? So I get a pallet or something, right? And you put the equipment on a pallet. It's setting stuff on the floor, in my opinion, is just very low. It's something we don't do. And I have my tools and everything up off the floor because we don't set stuff on the floor. It's just weird. I don't know. Hold on. I'm trying to go through some of these comments. You are absolutely right, and that's one of the things I was looking for. Is I have a float charger here for my 12-volt battery, and I just seen it earlier today. I think when I was going behind my, I've got a shelf full of wonderful stuff back there, and I have just bins full of electronics, and that's where my float charger is. And I was looking for it, and in a rush, I just grabbed this one because, you know, I just need a charge, man. Yeah, Jesus. Houston is not so bad. It's definitely not so bad. Let's go back to the oscilloscope so I can show you guys a couple other things. Your oscilloscope is going to always depend on what you're measuring, man. And it would be hard for me to try and show that to you without knowing what you're trying to measure, because somebody could easily say, oh, Justin said to do it this way. It'd be like, oh, man, you blew up your meter and it's my fault. Because all it takes is hooking one wire up wrong and you're going to bust it up. All right. So we got going on here. I'm going to disable my channel B. Okay. And channel A. Okay. So my channel A is set. 10x. Okay, everything's on 10x. We're good. I have my function generator set at, I don't know, let's go down to 100 hertz. Cursor, 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 up. Enter. Okay, so you can see in the new meters, it happens automatically. It just auto seeks. I do like these new meters. Let's see, hold on. All right, there we go. So I just disabled. I really hate how it always turns on channel B. That's very annoying for these meters, but you know, at $300, you just kind of live with what you live with. So you can see right here, I have a very crisp 100 hertz waveform, and we are good. So now this is a perfect sine wave that I was talking about. This is what you should see. Actually, hold on. Let me go back into it. Let's go mode. Stop. Cursor, 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 down, cursor. Run. Auto. Okay, so this is a perfect 60 hertz sine wave. So this is what comes in off your wall. And I use the function generator for stuff like this. If you want to set your oscilloscope up, if you're measuring power supplies or something, use your function generator, set it up so that your timing and your voltage is already set, and then you can go ahead and take your measurements. Because if you don't know if your power supply is good, then you know, trying to find the waveform is such a pain in the ass. So I'll use my function generator, this guy right here, to set it up, because I know what I should be seeing, and then you then connect your oscilloscope and actually see it. Let's see. Somebody, I don't know if you're currently on here, somebody asked me, why is it that they hook a light bulb up to your power supply when you're testing it? Now, I don't know if that person's currently online, but that was a very good question, because some power supplies only turn on when there's a load. Now, I can't say it's not too many, because it's some of them. But what it does when you hook up a load is you have circuitry inside your power supply. And on this one, normally there's a little card on your power supply that has got little pots on it. And what that circuit does is it monitors your output power, and what it does, it smooths it out. So if this is a 12-volt power supply, it detects the load and it adjusts the current and voltage to make sure it's at 12 volts. So if you have no load, sometimes you'll get like a waveform that's all over the place. So that's why people, when they're testing it out, they will hook up jumpers to it and hook up a load, like a tiny little light bulb, so that you can make sure that you have it under a constant load. Everything should be consistent. If you have a variable load, like this guy right here, this guy's probably going to be a variable load, because it's all over the place. If the battery sags, it's going to start doing some weird stuff. So I would never use that as a constant load. The light bulb, a 60-watt light bulb, a 100-watt light bulb, something like that, is a constant load. It's always consistent. And so that would be an excellent thing to hook up to a power supply. But with these guys being DC, I don't have a DC load here. I guess I could hook up something like this, my function generator, or like a little oscilloscope, something that is expendable. Hook it up on the positive and negative pins. It's not changing the amount of electricity it's pulling, so now I can check the circuitry. All right. I wish next time I do a live stream, I'm going to go ahead and I'm going to solder tiny little wires onto the power supply. Because if you were doing a lot of work on electronics like this, that's what you do, is you have a tiny little coil of wire, and you will solder a little jumper on there so that you can hook your probe on. This guy here. Some power supplies have test points. it'll say like TP1, TP2. Let's see if this guy has it. It's usually over near the outputs. And it's also near your DC circuit. And it's also after your rectifying diode. You'll have like test points. There's straight jumper wires on this guy. See this wire right here and right here? So if you know what you're looking for, you can clip on there, or you can clip on your diode. And if you're looking for a reference on a power supply, if you're looking for an AC reference, you can clip right here, especially on this guy. Look how the legs are right out here in the open. So you can clip on your neutral of your rectifying diode, and then you can take your measurements of your AC circuit, which is this guy, your fuse, your capacitors. And that's why I like the silicone mat right here, because you can flip it over like this while your AC is connected. And look at this, it doesn't really move around too much. The silicone is a little sticky. So what I do personally, let me get these wires off this battery, is, again, I love using these jumpers. There we go. So I clip the jumpers on the IEC, or you can clip them straight onto the rectifying diode, or straight on your bridge rectifier, because the two middle posts right here are for your AC waveform. So you can clip one on here, clip one on there, and then you take your power cord. Let's see, where's a good power cord that I can use? You would think as a Biomed I'd have power cords all over the place. Here we go. All right. Okay. So when you're testing out a power supply like this, you always connect it with jumpers unplugged. Okay. So you have your female IEC. I take my jumpers and I cram them down in there like that and clip it. All right. Take the other one. I'll cram it down the other side. And look, it keeps them nice and separated, and they have a good connection. Now, I'll take something like a vise. Now, don't take my word for this, guys. I mean, this is just what I do. So you guys want to know how I do things? This is how I do it, okay? I have my cord strapped into this. It is not going to tip over, okay? Because those jumpers are going to be live. Then you can take your cord and you can plug it in. And I just heard this guy clippity clap. Here's where you have to be careful. Guys, if you are not comfortable around electronics, do not do this, okay? Because if I were to lay my hand on this guy right now, this is live, okay? If I were to touch it, you would see 60 hertz. I'm going to show you. All right. I have my oscilloscope here. Let's take this guy off. Okay, remember I told you can take that clippy clap off on the end so you have just the point. And I also told you guys earlier about this isolating tip. This guy right here. Here's where I'm going to use it. Oh. Okay. So here we go. I put that guy on there so it helps protect me a little bit. And if you touch around on the board, can you see my oscilloscope there changing? See that? So right now, because I have this silicone mat, I don't have to worry about this guy sliding all around. I have it on the AC, so now I can test, let's say over here. I don't know if the camera can see it. I have these 4 points right over here, 1, 2, 3, 4. Those 4 are my bridge rectifier, okay? So what I'm going to do is I'm going to come over with my oscilloscope and I'm going to touch one of those points. Look at that. So you can see that I have AC through my bridge rectifier, okay? So without changing anything else, let's go to the DC side of the bridge. Okay, so the outer legs of your 4-pin bridge rectifier. Ooh. Hold on, I don't have my reference connected. Don't do this, guys. I'm going to do it because I know what I'm doing. But mind you, I have live AC on this board. So I'm going to clip on my negative leg. And now I can touch my positive. Okay, you see that line that showed up here? That shows me my DC, okay? So I'm referenced to my negative leg of my bridge rectifier, which is that 4-pin large flat pack. All power supplies have them, or they have 4 little diodes. You can see on this guy right here, there's my AC, comes in, and right here's my bridge rectifier. See this guy right here? So you can see negative leg, AC, AC, positive leg, okay? So what I'm doing is I'm connecting my reference on my scope to my negative leg, which is this guy right here. And then from here, I'm testing other points, okay? So let's continue on. So I'm clipped on my negative, and here I can go through and see all different sides, different areas of my AC. See that? So if I have a component that's bad, here's how you find it out, okay? And this oscilloscope takes a minute, so I apologize for that. Okay, you see it flashing? See that? I'm going to hit auto. And anytime you see a flashing like that, means that it is being told to turn on and off. Okay? So all these things, this is a good power supply, obviously. And let's see. I can't reach over too far. So you see these other flashes? See how they're happening really quickly? That is testing out the DC side using an oscilloscope. Mind you to always press the auto button. And this oscilloscope, I can see it. I don't think the camera shows it, but it's showing me that there's some activity on there. Here, let's press the auto button again. All right, and I'm going to go ahead and unplug the oscilloscope, or I'm unplugging the power supply. Mind you, there is voltage on this power supply for a period of time after you unplug it. A lot of power supplies have bleed down resistors, and a bleed down resistor means after you lose electricity, it diverts the remaining charge of these capacitors through a resistor someplace on the board, and it bleeds it down to 0. And you can test that with your scope, and you'll see the line going down, down, down. You can see it right there. It's dropping a little bit until it reaches close to 0 volts. Okay, then I can unplug my scope, and I unplug from my male IEC connector. And now, always remember to take your jumpers off your power cord. It is going to come by and plug this guy in, and you're going to have a couple gator clips floating around on your work surface that are going to be live 120 volts. Now, I don't know if you guys approve of those techniques, because obviously you can get shocked and whatnot. But mind you, I don't have other people in the room, and nobody else is near my workbench. All right, and that includes at work. If somebody's near my workbench, then I make sure that I don't do this type of work. I also have, oh wow, this is a heavy little guy. So I have a couple different types of vices that I use for this type of work. This one here has got rubber pads on both sides, and it's got a very heavy base. And if I'm going to test something like this PCB, right, there's a lip on this rubber right there. So there's a lip on the rubber before it reaches the clamp, and I set the PCB on there, and now look, it's going to be on there really well. Obviously, I need to tighten it down better. But that is on there. That is a secure way of testing it. Plus, you can articulate it so that you can reach stuff better, man. Because sometimes you got to look behind and see what component you're testing. And this is the best way to do it. Get yourself a PCB clamp or one of these pana vices with the wide jaws like I've got here, and hook it up so it's nice and static. Make sure it's firm, because there's nothing worse than having live voltage on something and it pops out, and trust me, I've done it. All right. So if I'm doing some serious power supply testing, I either get a block of foam, like packing foam, and I set it on that while I'm testing, because, PCBs, they stick to foam. They do not slide around, and that's safe. Or you get yourself a vise like this. Now, mind you, make sure that your vise is not touching a component, right? I wish I didn't have to say that, but I guess I do. A metal vise touching a component on a board would be very bad. So there's just a tiny little lip on this one, and it holds the very edges of the circuit board, so I know I'm safe. But just be mindful. Use proper work holding. Let's see. Hold on, guys. Let me catch back up on these notes. My instructor had me troubleshoot an infusion pump for a week, and what I learned from it was my ability to assess a problem and to apply what I've learned. Hands-on is the only way to do it. They had you checking an infusion pump for a week. I have these rules of repair, and you can see I've got them actually over here on my desk. And when I get a permanent office, I always hang those in there just as a constant reminder to myself, because I get burned by my own rules more than anybody else. And like rule number 1 is never trust somebody else's troubleshooting, guaranteed. But what you were saying there, rule number 4, it was already broke. Time permitting, every repair should be treated as a time to experiment and explore the malfunction to improve your skill set. I am a firm believer on that. There is a certain time, I will give somebody an hour or so to try and figure out what's going on, and then I'll help them out. But biomeds, we're constantly expected to do more with less. And in that, somebody has to figure out an efficient method for doing troubleshooting. So I'll give somebody an hour, and I almost never call tech support. It's so rare that I call tech support, and that's because they're usually useless, right? Now, if there's an error code or something that's not in the user manual, or if you don't have the user manual, then by all means, call tech support. But usually, they're useless. You can quote me on that. That should be like rule number 11. Tech support is useless, because they're such a pain in the ass. By the time you actually get to talk to somebody, you might as well just solve the problem yourself, right? But time permitting, yes, you should explore every single malfunction, because most people, what they'll do is they'll Band-Aid fix things, all right? And that's just one thing that just pisses me off, because Band-Aid fixes always come back. That's rule number 3. Band-Aid fixes always come back. So if you do a half-ass repair, you're going to see the job again, right? And your customers are going to be mad. Your patient might be injured. Who knows what could happen? So never ever Band-Aid fix. If I have to hold a piece of equipment, even ship it back to the manufacturer, I'm going to do that just because, you know, I don't really care. I don't care if they have their equipment. I would rather the equipment be 100% certifiable than put it back in service on a maybe. Let's see. If your power supply has a fan, then usually a dummy load is not needed. You know something, Bjorn? You are absolutely right. Most of these power supplies don't have fans. I do have this guy. It's a 10 watt, 250 watt, 10 ohm load. Sorry guys, I'm a little tired. I could hook this guy up as a load, you know, if I needed to do like some pretty hardcore testing on some of these units. But yeah, you're absolutely right. A lot of power supplies do have a DC circuit in them, and they do things like internally cool, like your PC fan in your computer. There's a fan inside them, and often, like even on this inverter over here, it's got a fan that will come on, so you have some sort of load. Bust out the isolation transformer for safety. You know, D-Rod, you are absolutely right. It's sitting right here behind me. It's right there, right over my shoulder. And yeah, I didn't. I'm still working on this bench. I'm thinking about mounting my isolation transformer right to the back wall. I mean, it doesn't have to be anywhere. I'm thinking about just mounting it to the wall, and when I need it, I'll just flick a switch, you know, and I plug into that. It's already got a power strip mounted to it. But you're absolutely right. When doing tests like this, yes, power supplies, it doesn't matter if you're testing from an isolation transformer, because if you have 60 volts on it, either leg, it doesn't matter, because usually most problems with the power supply is going to be in the DC side, not in the AC side. So, oh my gosh, guys. Anyway, I've got so much other stuff that I wanted to talk to you guys about, but I'm afraid I'm gonna have to cut this stream a little bit short. I think I've answered most of the questions. There's still some stuff I wanted to go over. You can see I've got my backpack back there. That normally is in my Jeep because I am an always ready type of person. And I wanted to show you guys some of the stuff that was in my bag. It's sitting right on my rotary axis, which is right there, next to my isolation transformer, which is right there. But that's my go bag. And a go bag or a 24-hour bag is, in my opinion, absolutely necessary if you're a biomed. You never know what's going to happen, right? So you could have a server that crashes on your system. You could have an electrical outage for your city. You could have a water main break, which I've had all these things during my career. You could have freezing weather. You could have inclement weather, whether it's a thunderstorm that rolls in and it floods out. You could have a hurricane, whatever. So I keep a bag. And this one right here is always in my Jeep. And the thing is I have to take this bag and I have to go through it every once in a while because, you know, my Jeep is out in Texas sun and right now it's out in the cold. So there's certain things that you always have to stay up on because they tend to not fair weather very much. So I have like this is my med kit on the outside. And my med kit has all sorts of supplies because if you're a military trained biomed, you also are semi-trained in medical. You're trained in self-aid buddy care, and you should be able to use a med kit with good success. And we as biomeds, we are around medical supplies all the time, and when they expire, like lidocaine, or if you use like Neosporin or something like that, that stuff expires all the time, and we find it everywhere on equipment. you get a Bovie or something and you open a drawer and there's a whole bunch of crap stuffed in a drawer. Well, some of it's going to be good stuff. I mean, I'll tell you right now, a lot of stuff that I have came from like carts and stuff. I have iodine swab sticks. I've got iodine prep packs. I have antibiotic ointments. I have tape. I have this really cool stuff in my full med kit in my Jeep, and I have like instant. They're instant stitches, okay? And what it is it's adhesive that you put on both sides of the cut, and then it's got zip ties, literally zip ties that you pull, and it stitches your wound back together. Whereas putting compression bandages on also help, but they don't help seal the wound. And if anything, you know, it might be good enough to get you to, you know, a doctor or something. But I'll tell you for a fact, stitches suck, all right? They're painful, and I've had them a couple times in my life. And instant stitches, a lot of ERs are evolving to that because you're not having to use needles, you're not having to use thread. You don't have to come back to get stitches out. So it's just adhesive that sticks on both sides of the wound. That's why I have my alcohol prep pads and my iodine prep pads, so you can clean both sides. You stick your adhesive on each side, and then you pull the strips to close the wound. And that will help with your bleeding problem, and it helps with sanitary issues, right? And if anything, a vast majority of stitches don't even have to go to the doctor. I mean, I even cut the end of my thumb off right there. I cut it off on a bandsaw, just like that big bastard right over there. And I tell you what, I used that bleed stop powder, and I used compression, and I was able to basically mend the end of my thumb without ever having to go to a doctor. And even though I have no feeling in the end of my thumb, you know, it's still a thumb. So let's see. I have a bunch of other stuff in this bag. I have Q-tips. Q-tips. You never know when you can use Q-tips. I use Q-tips all the damn time, guys. And you use them for applying medication. They're sanitary, which is why they're in this pill bottle. You use them obviously for cleaning your ears and stuff, but Q-tips are also very useful for applying things like lubricants. All right, so if you have lubricants or something like that, or if you want to touch up with like, well, if you're going to use alcohol or hydrogen peroxide, always use a Q-tip. You know, you drool some hydrogen peroxide on it, you dip your wound with it, and then you throw it out, right? You never like reapply the same Q-tip with your antiseptic, because you could contaminate your antiseptic, right? Let's see, I have ear protection in there. I have bandages. Like these are wrap bandages. Oh, let's see. I have Vicks Dayquil. This bag is in my Jeep. So let's say I feel like crap one day when I'm at work, right? So if I feel like crap when I'm at work, I can go to my Jeep and get any of this stuff to help me out throughout the day. So I have like nose spray. Let's say, like, even though I don't know if you guys have been sick very much this year, but masks do work. You know, I can say for me and my family, record low amount of sickness this year. Like no colds, throwing up, no nothing for like the last year. That's a blessing. Absolute blessing, guys. So I have ear protection over here, which are the earbuds, and I have eye protection right here. You can see I got my glasses. You don't know if you're going to be in a smoky, dirty environment, whatever, looking up at the ceiling, whatever it is, I have eye protection on here. And also, I don't know if you guys know this about me, but I used to be I used to train people on how to shoot handguns. So having extra eye protection is always, you know, a good thing. You know, I keep eye pro, here in my shop, but I keep it in my vehicle and stuff. You never know when you could use it. Eye protection is a good thing, man. So I have changes of clothing and stuff in here. I have changes of socks, regular toiletries, regular clothes. I keep at least 24 to 48 hours worth of clothes in this bag because, you know, how many times have they said, hey, you guys need to go home and get clothes and whatnot, and then come back. Shoot, I just run to my Jeep, grab my bag, and I go back to work. You know, that's how I roll, man. Let's see. I have this nice pouch in the back of this bag. Let's see. I think this is a 511 bag. I'm pretty sure this is. So this is an awesome bag. It's got a back plate right back here where you can set stuff if you need. But it's got a plastic insert, so it spreads the load across your back. Very, very nice bag. And then, of course, you guys have seen before that I'm an absolute nut about Leathermans, and here I have my Leatherman mutt. It's right on the side of my bag. So if I have all sorts of problems from stripping wires, cutting things, even something as simple as opening a box, I keep a fully loaded Leatherman mutt right here on my bag, ready to go, man. A Biomed is not very useful without its tools. So in my Jeep, I also have food provisions, and I have water, at least enough for a couple days, you know, and that's pretty simple, just a couple MREs, and I have half a case of water like underneath the seat of my Jeeps. But anyway, that I'm going to go through this bag. You know, I change out my clothing and everything every few months. It keeps everything fresh because, you know, when things sit stagnant, it's just not good. So that's one of the things I'm going to do tomorrow is go through this bag, make sure that all my medications and everything are in excellent condition, and make sure my med kit is fully stocked, and that I'll open like the prep pads and stuff and make sure they're not dehydrated. You know, it's just one of those things that you have to maintain your kit. But anyway, guys, do I use super glue? You know it, man. You know it. And actually, I don't have any in there. Maybe I do. There's this stuff called Dermabond, which is like super glue, but it's sanitary. I don't know what the difference is, because back when I was a mechanic, I don't know if it shows up on the screen. You can see maybe a little bit there. I have scars all over my hands. All over. I mean, I wish I could show you. I got scars here, here. I've got scars absolutely everywhere on my hands, man. I used to do like some bare knuckle boxing and stuff back in the day, and some of my knuckles are even I have old scars. Whenever they get really warm, like I put them in hot water, you can see like all the scars come out. So just you can see I have scars everywhere. So yes, super glue. It's a fantastic product, man. You pinch the skin together, you put a drop of super glue on. Also, why I have those Q-tips, and you put it on there, dab it, and you hold it and blow. Let it go. All right. I have solved problems with super glue, man. I love that stuff. Good on you. All right, D-Rod. Guys, I'm going to have to sign off as well. I have to go in for the kids and the family. Like I said, man, things have been kind of rough over the last couple days, so I got to go in and at least make sure that the kids and everybody are all right, okay? So y'all have a very good night. Thank you very much for watching, and I do have some other stuff planned that I wasn't able to get to tonight, so we'll have an excellent video next weekend, all right? So thank you all for spending your Saturday evening with me. And I hope to release another video this next week. I'm going to do one on ECG. It's going to be a basics video on ECG and about leads configurations and, you know, why we do ECG waveforms. Okay, so that's going to be my next video. Thank you all for watching, and y'all have a good night, okay?